So unit 4, lesson 4. So now we're just talking about quadratic inequalities of two variables. So last class we shaded straight lines and shaded above and below. Now we're going to shade above and below quadratics, which is parabolas. Okay, so that's the only difference. It's pretty simple, but we're going to go ahead and do a quick little investigation and one example to kind of explain why what is what, I guess, is the best way to say it. So first off, let's talk about part A. Okay, so explain why the point 30 is in the solution of the region x squared minus 3x minus 4. So we're just going to prove that this is a solution to that inequality. So I'm going to put, that's x, that's y, just like we did in our warm-up. 0 greater than or equal to 3 squared minus 3 times 3 minus 4. Well, that gets us 0 greater than or equal to 9 minus 9 minus 4. 9 minus 9 is 0. With the minus 4, is 0 bigger than negative 4? It is. So we just confirm that that point is in the region. Okay, sorry if I go pretty fast in the mental math stuff. Okay, so this next part, what we're going to talk about is there's two regions that it possibly can be. We can either be greater than or equal to x squared minus 3x minus 4, or we can be less than or equal to. Okay, you could also be less than or greater than. Just same rules apply, dotted line and solid line. So it's the same as last class. Okay, but I want you guys to do so we can just kind of go around here. So see, Colton, you can do this one, and then Sarah, I want you to test and tell me which one it's true for. Okay, Amanda, and then Nick, and then Cody, and then Josh, Tristan, Rye, and then I'll show you this one. I'll do these two real quick to show you what I'm talking about. So 2, negative 2. What I'm gonna do is I'm gonna plug that in, and don't worry about which one you put into. You just gotta figure out which side's bigger. So negative 2 is a y, so I just put equal signs for mine. And then I'm gonna put 2 in. 2 squared is 4. Okay, I'm getting the squared from right there. So 4 minus 2 times 3. Okay, that's gonna be minus 6 minus 4. So negative 2 equals negative 6. Which one is bigger? The negative 2 is, right? It's bigger. So that means that this one goes up here for the bigger graph, the greater than or equal to. Does that make sense? The left side's bigger. So since this side's bigger, y is bigger. Okay, so that one I just did is going to go over here. 2, negative 2 is in this box. Okay, I'll try negative 5, negative 2 real quick while you're doing yours. So negative 2, so I already did this one. Okay, negative 2 is on the left again. So I just got to plug in negative 5. So negative 5 squared is 25 minus, let's see here, be negative 3 times negative 5, be plus 15, and then minus the 4. So that's going to be 40 minus 4 is negative 2 and 36, which is bigger? The 36 is bigger, so that means the right side's bigger, which is this one right here. Okay, so the other point I just did is going to go in the bottom section. So that's going to be over here. Okay, does that make sense? Okay, because the right side's bigger, so we want to see how that bigger side's this side. Okay, so, all right, what do we get for the first one, Colton? Goes on top, good. Okay, Sarah, did you get the second one? It's on the bottom. Okay, good. And Amanda? Top, good. Bottom? Or yours is 1. What do you have, 1, 4? You have 0, negative 7. Oh, yeah, I got you. 0, negative 7. Okay. Top 1, 4, good. Bottom, Josh. 7, negative 1. Okay, good. Bottom. Okay. Okay, and right, 8, 5. Bottom. Good. Okay, so what we figured out is all these points are greater than or equal to this graph. All these points are less than or equal to the graph. So here's my less thans and my greater than. Okay, well, what does that mean in terms of on the graph? So what we're going to do now is just keep track of those points. I'm going to scroll down and we're going to plot the points on the graph. We'll do the greater than on the left, the less than on the right. So here we go. Close, not quite. Okay, so applying the points. So 3, 0 is right here. 0, 0 is right here. 0, 3 right here. 1, 4 right there. And 2, negative 2 right there. Okay. Let's do the other ones and we'll compare. The other ones, negative 3, 0. 0, negative 7. 7, negative 1. Negative 4, 2. 8, 5. And negative 5, negative 2. Okay, so then what do we notice? What's that? Yeah, they're more spread out on this one, yeah. But more what Colton just said, yeah, these are all in the parabola. These are all outside the parabola. Switch up the color for that. Okay, these are all outside the parabola. Okay, that's not a coincidence. Okay, that is indeed what we're talking about today. So think about this. This one was the greater than equal to, right? Well, the easiest thing that I like, use the vertex as your anchor point. What I mean by that is right here. That's my anchor point. Okay? Now, from this point, if I was to tell you, I wanted you to do greater than equal to, would you go above that point or below it? Above it. And directly above it puts you where? Inside the parabola. So that's what you shade. Does that make sense? Okay, a lot of people get confused when they flip. So if I flip this, just so I show you here, and let's say I said greater than equal to. So here's my anchor point right here. And I said greater than equal to, where would you go? Outside. You'd be outside of it. So use that as your anchor point. It'll work every time. Okay, same thing here. This is my less than equal to. Here's my anchor point. I went less than down here, so I shaded all this stuff on the outside of it. Okay, so think of the vertex as your anchor point. Okay, that's what C and D is telling you. Okay, let's go and switch now to the next page and kind of zip through the kind of a checklist for you. Okay, all this stuff I kind of talked about, but this is kind of the steps to graphing. Draw the graph using the intercepts, kind of find the vertex the best you can, and then notice if it's equal or not. Remember, if it's not equal, it's a dotted line. Okay, and if it's equal, it is. If it's equal, it is solid. Okay, they're going to tell you to use a test point. And what they mean by that is you can also, if you're not understanding what I'm saying with greater than equal to, just try inside the parabola or outside the parabola. Because if you try one of the points like we did last time, if you try that and it doesn't work, what's that mean? If you try a point outside the parabola and it doesn't work, what does that mean? Your answers are all right, inside. Okay, so if I tried, just a little random example here, if I had a parabola here and I tried this point here, okay, and that point did not work, so then I automatically know that I have to be inside for my solution. It has to be one or the other, okay, or on the graph, which on the graph because it's equal to. Okay, is there any questions on that? Okay, pretty straightforward. Okay, so let's go ahead and try the one example we have, and then we'll call it a day. All right, so what do you think you want to do first? Because on the procedure it says find your x-intercepts, your y-intercepts, and then graph, right? So how can I find my x-intercepts? Without using calculator. This chapter is not using your graphing technology. What's that? Yeah, factor it, exactly. Okay, let me see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's just go by twos here. So this right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so what is my y-intercept though? That's pretty easy. 20, yeah, that's why, if you're watching me, that's why I was counting there. So that's 20, so that's going to be right there. That's your y-intercept of this parabola. Okay, and then like Sarah said, I'm going to factor this. Well, it's kind of backwards, so it's a little bit difficult, but just know this. Since it's a negative x squared, that means you're going to have x's down on the end. Okay, and then just kind of think about backwards. Since it's a minus, it's still like a difference problem. So you want multiple of 20 that are 1 apart. Okay, 5 and 4. Good. Now, this is the tricky part. I'm going to put a 5 here and a 4 here. We have to figure out where the signs go. We want what type of 5? Positive. So we want the plus to be here because that 5 multiplies with that positive x. Okay, we want the minus here because that multiplies with that negative, that 4 there. So it's kind of backwards. All right. Okay, by doing this, this gives us our x-intercepts of 5 and negative 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, and this is just giving us a rough drawing of a parabola. Okay, really this is stuff that we should already know. Now, what do we know about the vertex? It's what? Right, it's the anchor, but in terms of for parabolas, all vertexes are what? Highest or lowest point that is centered. Yeah, it's symmetric was what I was trying to get at. It's symmetric, right? So we have these two y-intercepts, so the vertex should be exactly halfway between them. Okay, well this is, we count it, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. What's half of 9? 4 1/2. 4 1/2 would be right here. So right about here is where your vertex is going to be. I mean, I'm just doing it roughly because that's all we can do right now. I know it's going to be higher than my y-intercept because that vertex is the what? The highest point. Okay, so now I'm going to draw my parabola like so, like so. So now we have a graph. Now we ask ourselves, what's it want? It wants less than. So what type of line does it want? Dotted. Sorry, I was talking about the graph line, Nick. I want a dotted line, so I'm going to go ahead and dash these out. I want a dotted line because it's less than, not less than equal to. Let me erase this up here so we can see this. Okay, and it's less than. So I want less than, so as Nick was saying, I want to use the vertex as my anchor. I want to be below. So I'm going to be right in this region here. This is your solution region. Okay, and that is it for today. Okay, let's do one more thing actually. Sorry, I want to do a test point real quick. What's the easiest point I could test in here? Oh yeah, let's test 0, 0, just to make sure we're right. Okay, so I'm going to test 0, 0. So that means I have 0 is less than 20 plus 0 minus 0 squared. So is 0 less than 20? Yes. So it is a correct answer. Okay, and that is it.